Hello class 8. The topic that we are going to discuss is the one that you see written on the board, which is light, or to be more precise, light energy. Because we know light is a form of energy. Now how do we define, so to say, light energy? It is the form of energy which produces a sensation of vision in our eyes, okay, or in us, so to say. So it is a form of energy which causes in us, let me say, a sensation of vision. Like sound energy, like that you all had studied in class 7. So sound energy it is the form of energy which produced in us the sensation of hearing. Alright, likewise it is the energy which causes in us the sensation of sight or sensation of vision. Sensation of sight will also be. Okay, so this is about the definition of your light energy, remember? Now the other thing I want to tell you is, do remember light travels or light energy travels with a certain speed. Okay, now if I am to run, so the medium surrounding us is air, so we are running in air, so to say. So I can run with a certain speed in air. Okay, now if my surrounding medium is water, I'm still landing on the ground, of course. Okay, I'm still on the ground, so to say, but the surrounding medium is water, and say I can breathe. Okay, the only thing that I can do is I can breathe in water. So do you think if I try to run in water, of course I will be able to, it's not that I won't be able to, I will be able to run, but do you think I will be able to run with the same speed with which I can run in air? Okay, obviously not. Why? Because it'll be difficult for me to run in water, simply because water offers more resistance to my movement. Now that's a different thing to talk about, okay, but do remember it resists our motion more. Water resists our motion more. Likewise, like us, light also travels with certain speed in different media. Media is the plural of medium, remember. It is not mediums. The plural is not mediums, that of medium. Okay? The plural of medium is media, remember. So, light also likewise travels with different speed in different media. Light travels with a certain speed, certain faster speed, so to say, in air. It travels with a bit of a lesser speed in water. It travels with a, further lesser speed in glass, and so on and so forth. So to say, what I'm only trying to say is, light travels with different speed in different media. And let me at least give you this value. Speed of light in air, or so to say also in vacuum. Now what is vacuum? Vacuum is a space where there is no air. So to say, we can't breathe, of course, we will die in vacuum, of course, and even if I try, say for example I can live in vacuum, even if I speak, you won't be able to hear me. Why? Because sound needs a medium to travel. You are being able to hear me because my voice is coming out of my mouth, of course, the sound that I'm producing is coming out of my mouth, traveling through air that is in between me and the mic of the camera, of course, and reaching the mic. Okay, now in vacuum there will be no air, so no medium through which sound can travel, and therefore we can't, you won't be able to hear me speak, even if I can live. Alright, which of course we can't. We can't live in vacuum, we can't breathe in vacuum. So, speed of light in air, in vacuum, or what am I saying? The speed of light in air or vacuum, so to say, is 3 into 10 to the power 8 meters per second. So to say in 1 second, Air is traveling 3 into 10 to the power 8 meters. Alright, or you can also write this as 3 with 1, 2, 3, 4, 5 kilometers per second. Okay, so to say, light travels 3 lakh kilometers in 1 second. Can you imagine how fast the speed is? In 1 second, 3 lakh kilometers. Okay, 3 lakh kilometers is much more than the width of total India from top Jammu Kashmir, alright, to the bottom, of the mainland. What is that? Kanyakumari. Alright, I think that whole length, okay, is about 1,000 kilometers. I don't think it's even 1,000 kilometers. Alright. Is it not 1,000? Of course it is. The length of India from top to bottom up to Kanyakumari from Jammu Kashmir is some 1,000 kilometers. Alright, but this is 3 lakh kilometers, remember, in 1 second. Okay, so this is quite a speed. The fastest person so far is Usain Bolt. Okay, Usain Bolt can run 100 meters. Okay, 100 meters in about 10 seconds, 9 point something seconds, but let us take that to be 10 seconds. So in 10 seconds, the fastest human being can run 100 meters. But light in 1 second can travel 3 lakh kilometers. So this, we can't even imagine how fast this is. This is a really very fast speed. And so far, light is the thing which travels with the fastest speed for us. We haven't seen anything that travels faster than light so far. Understood? So light is the fastest moving, fastest traveling, entity, so to say. Okay, nothing can travel faster than light so far. So do remember this value of speed of light in air or vacuum. 3 into 10 to the power 8 meters per second, or 3 lakh kilometers per second, so to say. Now the reason I told you about speed of air, speed of light. Now the reason I told you about speed of light in air or vacuum is because we are going to discuss a topic. I hope you've copied this. Alright? You can pause the video. You can rewind the video, pause it and copy if you haven't copied. Copy everything that we write on the board. The topic that we are going to discuss is something called refraction of light. Refraction of light. Now in class 7 you've studied about reflection of light. Okay, wherein what happens is you have a mirror or a very plain and very smooth surface. Light comes, hits the surface and it gets, or so to say, it bounces off that shiny surface. Okay, so that was reflection of light. You studied about laws of reflection also. Okay, the incident ray, the reflected ray and the normal all lie on the same plane. Okay, that was law number 1. Law number 2 was law number 2 was the angle of incidence is equal to angle of reflection. Remember? Okay, now that was reflection of light. This is refraction of light, R-E-F-R-A-C-T-I-O-N, refraction of light. Now let us see what this phenomenon is. Let us start with its definition. My handwriting, I don't think, has improved. The phenomenon of bending of light. The phenomenon of bending of light when it moves from one medium to another, is called refraction of light. It's called refraction of light. So what are we talking about? We are talking about bending of light when it moves from one medium to another, when light moves from one medium to another. Okay, so this event of light bending when it moves from one medium to another is what is called refraction of light. Okay, let me draw it here itself. So say if this is air and this is water. So this is the water surface, so to say, or rather this is the surface of separation between the two media, air and water, in our example. Now what we can do is we can draw a vertical line. So to say, we can draw a normal. What is a normal? Normal is a perpendicular which we draw to the surface of separation. So whenever you hear the word normal, be it in reflection of light that you've already studied, or be it refraction of light, you need to understand normal means perpendicular. It's a mathematical term actually. So to say this angle is 90 degrees, remember that, a right angle. Let us name the normal. Normal is N-O-M. Norm. Norm is the normal. So say for example, a ray of light is coming this way. A ray of light is coming this way. At an angle of incidence, I. I is the angle of incidence, remember. And what is angle of incidence? Let me first of all name this ray of light. AO is the ray of light which is coming in this direction, and AO is called the incident ray. The ray of light which is coming and hitting the surface is what is called the incident, D-E-N-T, incident ray, remember. And this angle which the incident ray AO makes with the normal is what is called the angle of incidence, D-E-N-C-E, remember, angle of incidence. So I again repeat, the angle which the incident ray makes with the normal, mind you, not with this line. We are not talking about this angle. This angle is not the angle of incidence, remember that. Angle of incidence is this angle, and it is the angle which the incident ray makes with the normal. So I is the angle of incidence, remember. Now get one thing very clearly here. Compared to air and water, which one is more dense? Which one has a higher density? Okay, water is more dense than air. Alright, so in that example of me running in air and water, it is difficult for me to run in water. Why? Because water has more density. Water is more dense, therefore it offers more resistance to my movement. Understood? Whereas air has lesser density, less dense, so therefore air offers lesser resistance. It is not that air doesn't offer resistance, remember. Air also offers resistance, but it offers very less resistance compared to water. So likewise, water also offers more resistance to this ray of light coming. And therefore what happens is, what am I saying? This ray of light is coming with a certain speed in air. To be more precise, it is coming with 3 into 10 to the power 8 meters per second. This amount of speed, with this speed, this ray of light AO is coming through air. Okay, now it wants to enter water. Now once it enters water, what happens is its speed is reduced because water is more dense. Therefore, since its speed is changed, what happens is the ray of light bends towards the normal. It bends like this, the ray of light. Okay, and what happens is it bends towards the normal. Now this is not just true in case of air and water. In case of any rarer, in case of light coming from any rarer medium to a denser medium. This is the first medium, this is the second medium. So to say, if the second medium is the one to which the ray of light is entering, remember. If the second medium is denser, then what happens is the ray of light bends, and it always bends towards the normal. This is the normal, okay, and you can see the ray of light is shifting towards the normal. This phenomenon of bending of light, when it moves from one medium to another, is what is called refraction of light, remember. So this is your angle of refraction R, and this ray of light that has bent inside the second medium is what is called the refracted ray. Okay, so the angle with the refracted ray, let me name it OB, is your refracted ray. So the angle which the refracted ray OB makes with the normal is what is called the angle of refraction. Remember that. Now, to tell you a fact, bending of light also takes place when a ray of light moves from a denser medium. D is the denser medium now, okay, R is the rarer medium. So a ray of light is coming from a denser medium. Let me make it a bit more straight. So a ray of light is coming from a denser medium. AO is our incident ray. NOM, say for example, still our normal. Okay, so when a ray of light is coming from a denser medium, say glass, or water also could be, okay, to air. So when a ray of light is coming from a denser medium to a rarer medium, what happens? Again, bending of light happens in this case also. Okay, in this case what happens is the ray of light bends, but it bends away from the normal. It bends away from the normal, remember. So AO is the incident ray, OB is the refracted ray, angle I is the angle of incidence, and this is the angle of refraction, remember. Now, of all the things that I've spoken so far, the most important ones are what is refraction. Of course, you need to understand that, and you need to understand when a ray of light comes from rarer to denser medium, it bends, and it bends towards the normal. You have to understand this very clearly. And when ray of light comes from a denser medium to a rarer medium, again it bends, but in this case it bends away from the normal. When ray of light comes from denser to rarer medium, don't forget. And AO, let me write here, AO is called your incident ray. It's called your incident ray. OB is your refracted ray. You need to copy all of these that I'm writing. Angle I, or simply I, is your angle of incidence, DENCE, whereas this is DENT. Angle R is the angle of refraction. It's called the angle of refraction. Likewise, NOM is your normal. Let me write it over here. NOM is your normal. Alright, class 8. Now, for the very first video lesson, I think this much will be enough. In the next class, we'll talk more about this. But do understand what is refraction and what happens when ray of light comes from rarer to denser medium, and also what happens when ray of light comes from denser to rarer medium. Do not forget.